Hello, everyone. Today we're going to start the new course, which is the Introduction to Electromagnetism. We will start this new course from the chapter 22 of this book. So I suppose everyone has either bought or downloaded this book. Now let's start from chapter 22. In this chapter, we will learn some electric phenomena, which are fundamental phenomena or concepts about charges, forces, and fields. First of all, we're going to learn what is electric charge. So the electric phenomena depend on charges. You will learn there are two different types of charges, which are defined to be positive charge and negative charge. And then we're going to introduce two types of elements, which are electrons and the protons. And we will learn protons are the sources of the positive charges and electrons are the sources of the negative charges. Or we can call they are the basic charges of ordinary matter. And then we're going to learn something about charging. Charging is something transfer of electrons from one object to another. For example, when you charge your, let's say, phone or charge your laptop, actually there are some electrons transferred from your charger or from the let's say the circuit from the wall into your device. So this is the charging. And then what we're going to learn is how do charges behave. We'll learn some basic rules of different behaves between charges. For example, two charges of the same kind repel each other, and two opposite charges attract each other. And small neutral objects are attracted to a charge of either positive or negative charge. And charge can be transferred from one object to another object, and charge is conserved. And in your lab, you will do some simple experiments to see what happens when you get some positive or negative charges on an object. And then we're going to learn what are the conductors and insulators. So conductors are the material through or along which the charges move easily. For example, the wires. Usually, for example, when you charge your phone, there are some conductors in the wire. So the wire can transfer the electrons from the circuit in the wall into your phone. So this is conductor. However, you don't want to let's say you want to seal the conductor for your charger cable by something with materials on or in which that the charge is immobile. So that thing is called insulator. So insulators are the things or materials on or through which the charge is difficult to move or cannot move through those materials. So that's insulators. So in daily life, we need a lot of conductors and insulators. For example, if you pick up your phone, you will see the, let's say the shell or the case of your phone, the back cover of your phone, that's all insulators because we want to, let's say, insulate the charges from the phone to your hand. And inside the phone, of course, there are a lot of conductors which are used to let the charge moves in the, let's say, chips or different parts of the phone so that the phone can, the cell phone can work properly. That's two different types of material. And then we'll introduce Coulomb's law. So Coulomb's law is a law or an equation which can be used to calculate the force between two charges. Once you know the charges of the two particles, and you know the distance between the two charged particles, you can use this law to calculate the magnitude and direction of the force. And then we'll introduce a concept which is electric field. The electric field is defined in this way. When you put a charge in space, and then if you test the force by using another, let's say, positive charge surrounding this charge, you can calculate or you can measure the force, magnitude, and direction. If you plot those forces in the space at different positions and connect them in arrows, you will see it seems like there is a field surrounding the charges. Then this type of field is called electric field. So we developed the idea that charges create an electric field, and the electric field of one charge is the agent that exerts a force on another charge, or charges interact via electric field. The electric field is present at all points in space. So why are electric charges important? I think we don't have to talk about too much. Everyone knows how important it is. If there's no charges, then there's no electronic devices. There's even no, let's say, no lights, no any electric devices cannot work, including the lights in the classroom, of course. So it's very important. So we should start to learn it from very basic idea. And from there, we're going to learn more and more by steps. Okay, I suppose you have read the chapter 22 before this lecture, and you can test yourself or test your reading by answering those questions. See if you are good at those questions. But on class, I'm not going to introduce those questions and answers again, because you can always check it in the slides. And the slides is shared with you via Google Drive. Okay, now let's start the content of this chapter. So we will start to introduce charges by doing several or a systematic set of experiments. What we can do first is let's take a plastic rod that has been disturbed for a long time and then hang it here. And then let's pick up another undisturbed plastic rod and bring it close to the hanging rod. Then you can imagine what will happen. Nothing will happen. The plastic rod hanging on the ceiling or somewhere, it doesn't move at all. That means there's no force between those two plastic. So we will say the original objects are neutral. So we call it neutral because they're not charged and there's no force between those two plastic rods. This is experiment 1. Now let's move on to experiment 2. Let's wrap both plastic rods with a wool. And then once you rub the plastic rod with wool or hair, when you put your plastic your plastic rod rubbed with wool closer to the other rod, which is hanging here, you will see it moves away from the rod in your hand. That means there's some repelling force. So the conclusion from this experiment is two glass rods rubbed with silk or rubbed with or rubbed with the wools, they repel each other. So there's a long-range repulsive force requiring no contact between two identical objects that have been charged in the same way. And later on, in later slides, we'll learn actually once you rubbed this rod with hair or wool, this rod, this plastic rod is charged by negative charges. And then negative charge repel negative charge. So they're repelling each other. Now, the third experiment. Bring a glass rod that has been rubbed with silk close to the hanging plastic rod that has been rubbed with wool. What happens is these two rods will attract each other. So after this experiment, what we can conclude is these particular two types of rod are different materials and charged in a different way, and they attract each other rather than repel. And in later slides, we will learn actually after you rub the glass with the silk, the glass will be charged by positive charges. So this is positive, and the other plastic rod is negative. So plastic attract negative. Okay, experiment 4. Let's see some factors which affect the forces. So rub rod with wool or silk and observe the force between them. These forces are greater for rods that has been rubbed more vigorously. That means if you rub the rod vigorously, that means you put more energy on rubbing this rod, and this rod gains more charges. So that means more charges result in greater force. This is number 1 rule. The number 2 rule is the strength of the force decrease when separating the rods, or when you increase the distance between those two rods. So that means distance is another factor to affect the magnitude of the force between two charged rods. The force between two charged objects depends on the distance between them, and also, it didn't say here, but also it depends on the strength of the charges on both of the object, or both on both of the rods in this case. So actually, these two rules are the basic idea of Coulomb's law. Later on, we'll learn Coulomb's law in equations. The basic idea is the more charge you have, the stronger force you have. The longer distance you have, the weaker force you have. That's the basic idea. Nothing special, nothing complicated. It's just describing the force strength between two factors, depending on two factors, which are the distance and magnitude of the charges. Okay, now let's see experiment 5. Hold a charge. For example, a rubbed plastic rod over small pieces of paper on the table. What you see is the pieces of paper will leap up and stick to the rod. That means a charged glass. That means the charged plastic rod attract the papers, but the paper has no charge on it. It's neutral. So that means a charged rod or a charged plastic rod attract the neutral objects. The same thing will happen if you charge the glass rod to put it closer to the paper. It also attracts the paper. So no matter it's which type of charges, once the object is charged, it always attracted neutral objects. However, a neutral rod has no effect on the pieces of neutral paper. There is an attractive force between charged object and the neutral object, but there is no force between two neutral objects. Okay, if you rub a plastic rod with wool and a glass rod with silk and hang both by threads some distance apart, both rods are attracted to a neutral object that is held close. So there is an attractive force between a charged object and neutral object. So the same conclusion as we did in the rod to paper experiment. Okay, so here are some questions. I suppose you can answer the questions by yourself after reading the book. Okay, experiment 7. Rub a hanging plastic rod with wool and then hold the wool close to the rod. The rod is weakly attracted to the wool. The plastic rod is repelled by a piece of silk that has been used to rub glass. So the silk starts out with equal amount of glass charge and plastic charge, and the rubbing somehow transfers the glass charge from a silk to the rod. And other object, after being rubbed, attract one of the hanging charged object, either plastic or glass, and repel the other. These objects always pick up small piece of paper, and there appear to be no object after being rubbed pick up pieces of paper and attract both of the charged plastic and glass rod. So after all of this experiment, what does it say? Or what conclusion do we have? Now, if you hang the charged plastic rod and a charged glass rod, no matter what you get, no matter what you do for the third rod, once it's charged, the third rod will attract one of those two rods and repel the other one. So that means there are only two types of charge. We can call it plastic-like or glass-like charges. There's no third kind of charge. So here are some summaries of the previous slides. Number 1, frictional forces such as rubbing, adding something called charge to an object or remove it from the object. The process itself is called charging. More vigorous rubbing produces larger quantity of charge. There are two and only two kinds of charge. For now, we will call these plastic charge and glass charge. Other objects can sometimes be charged by rubbing, and the charge they receive is either plastic or glass charge. And then more importantly, if the two charges are the same kind, or if we call it like charges, then they repel each other. And the object charges attract each other. It didn't mention, but there's a third rule, which is any charge, no matter it's positive, no matter it's, let's say, plastic-like or glass-like charge, they always attract a neutral object. Number 4, the force between two charges is a long-range force. The size of the force increases as the quantity of charge increases, or when the distance decreases. So there are only two factors which affect the force between two charges: the magnitude of the charges or quantity of the charges, and then distance. Neutral objects have equal mixture of both plastic charge and glass charge, because if you put, let's say, a plastic charge and a glass charge, if they're at the same amount together, then the object becomes neutral. So that means neutral objects have equal mixture of both plastic and glass charge. The rubbing process somehow managed to separate the two charges, which is, let's say, plastic charge and glass charge. And later on, we'll learn those two types of charges are called positive charge and negative charge. Okay, next experiment. Charge a plastic rod by rubbing it with wool. Touch a neutral metal sphere with the rubbed area of the rod, which is shown here. And then you will see this metal sphere acquires plastic charge. The metal sphere then picks up small pieces of paper and repels a charged hanging plastic rod. Means when you put the charged plastic in contact with the metal, they share the charge. So the metal gets some charges or acquired some charges from the plastic rod. The metal sphere appears to have acquired a plastic charge. Charge can be transferred from one object to another, but only when objects touch. Charge a plastic rod and then run your finger on it. If you run your finger on it, what happens is the rod no longer picks up small pieces of paper or repel a charged hanging plastic rod. That means after you run your finger on the rod, on the charged rod, then the rod is no longer charged. It becomes neutral. So why? Because as we said, when your finger contact the rod, you're kind of sharing the charges on the rod. However, your body is sharing the charge with the rod, but your body is too big compared to a small rod. So if you share the charge with the rod, then your body almost take all of the charges. Then this small rod becomes almost neutral. Then when it's neutral, it no longer pick up or attract the neutral papers. Removing charge from an object, which you can do by touching it, is called discharging. Next experiment. It's let's say an extension of the previous experiment like this one. This time, we still use a charged plastic to touch the metal. However, you put another metal close to the first one, and you connect them by plastic rod. So what happens is, as we expected, the same thing as before, this metal sphere will get charged from this charged plastic. However, this metal doesn't. It remains neutral. And then if you replace this plastic rod into a metal rod, what happens is this metal sphere will get the charge from your charged plastic, and then this metal sphere also gets charged from the charged plastic and this charged metal. So what does it mean if you compare the previous experiment and this experiment? That means metal is a conductor. Charge moves easily through it, if there is a metal and if there is charge here, the charge can move along the metal and get to the other metal. Glass and plastic are insulators. Charges remain immobile. So if you put a plastic rod here, even though this metal is charged, the charge doesn't move from this metal to the other one. So that's the difference between those two types of materials, conductor and insulator. Let's have a little summary here. There are two types of materials. Conductors are material through or along which the charge can easily move. Insulators are the materials on in which the charges remain fixed or immobile. The charge can be transferred from one object to another by contact. So we have been calling those two types of charge as plastic-like charge and a glass-like charge. However, the modern names of the two types of charge, who is named by Benjamin Franklin, are positive charge and negative charge. So he established the convention that a glass rod that is rubbed with silk to be positively charged. And the charges on this rod is called positive charge. Any other object that repel a charged glass rod is also positive charged. And any object that attracts the charged glass rod is negatively charged. Therefore, a plastic rod rubbed with wool is negative. This convention was established long before the discovery of electron and the protons. And now let's introduce the last slide for this lecture, for this class. What are the basic negative and positive charges? The basic or elements of negative and positive charges are in atoms. An atom consists of a very small and dense nucleus, which is shown in red here, surrounded by a much less massive orbiting electrons. Those green area represents the electron. The electron is very movable, so it's very flexible. It's moving surrounding the nucleus. So sometimes we call it like a electron cloud because it's always moving. So that's why we put a big sphere here to demonstrate the electron distribution like a cloud. The nucleus contain both proton and neutrons. And the protons are the basic elements of positive charges. And then the electron is the basic element of negative charge. The scale of atom is very small. It's in 1 angstrom. 1 angstrom is the 10 to the power negative 10 meters. So it's a very small unit. And atom is very small. The proton or electron, they're even smaller because they're the component of a individual atom. So that's the fundamental of or elements of positive and negative charges. Okay, let's stop here for this lecture. We'll continue our lecture begin with the ideas of the atoms to further concept like the Coulomb's law in next lecture. Okay, thank you for listening to this class. This is our first class. I look forward to the second class. Bye-bye.